Hi guys, today we're going to add and subtract radicals. Last week, our last lesson, we were multiplying radicals, and we could multiply anything together as long as the index was the same. Remembering that the index is this little number inside the check mark telling us what the root is. But when we are adding and subtracting radicals, we have to have a like radical, which means not only does the index have to match or be the same, so does the radicand. The radicand is the value underneath the radical symbol. So if both of those match, then we can add or subtract radicals. And we need to simplify everything first. And then it becomes just like combining like terms. We just have to add or subtract the coefficients and keep the same radical, meaning that it has the same index and the same radicand. So if you take a look at example number 1, you'll notice that we have every one of our indexes are the same, remembering that when it doesn't have one, it's understood to be a 2. And all of our radicands are 7, so we can go ahead and combine these and just treat them as like terms. Notice there's a negative sign out in front of this one, which means that's a -1. There's nothing outside here, which means that's just a +1. And then we have another -1. So now we're just dealing with the coefficients. So a -1 plus a 1 will cancel themselves out, and then we're left with just a -1 times the square root of 7. So we would say that we've got -1 times the square root of 7, or we could just write it like the negative square root of 7. Looking at example 2, you'll notice that, again, our index is a 2. I know that because it isn't there, which then I know that it's a 2. The radicand in each case is 3ab. And whether it has a variable or not, as long as it matches, that means that we can combine these two radicals. So since the index and the radicand match, we can just deal with the coefficients, the 5 minus 3. So I've got 5 times the square root of 3ab minus 3 times the square root of 3ab, which simply gives me 2 times the square root of 3ab. It's as simple as that. So if your index and your radicand match, we can just combine them. However, life isn't always that simple. And sometimes we have problems where the radicands don't match. The index has to match because we can never ever change that. But the radicands, on the other hand, we know that we can change those depending on if they are able to be simplified, which is what our previous lessons have all been about. So if you'll note here, our indexes match, but here we've got a radicand of 6, and here we have one of 54. So therefore, I can't really change the 6 too much. Its prime factorization is just 2 times 3. 54, on the other hand, I really need that to be a 6 to match with this guy. So since that's what I need it to be, that's what I'm going to divide 54 by. That would be 9 times 6. Now, my 9 can be broken into 3 times 3. My 6 can be broken down, but I don't really want to break it down because I want that to be left because I want it to match this guy. Remember that we are taking the square roots, so that means we're looking for groups of 2. I have a group of 2 3s, which means I can bring that out to join in that 3 that's on the outside there. And I would do that by multiplying. So that means I can bring down my 2 radical 6. I'm going to take my 3 times my 3 out there, which is going to give me a 9. And then I'm going to have my leftover 6 inside of there. Again, I didn't break that down any further because I don't really want it to be different. I want that 6 to match. So I've got 2 times the square root of 6 plus 9 times the square root of 6, which gives me 11 times the square root of 6 as my final answer. Taking a look at example 4, you'll see that we've got 3 terms, or 3 values this time. So both of these guys are 7s, so wouldn't it be delightful if that 28 would be a 7? So that's what I'm going to divide it by. And 4 times 7 is 28. I want to keep that 7 to match with these guys. Lucky for us, that 4 breaks into 2 times 2. And since all of my indexes are 2, I need groups of 2. So that means I can bring these 2 guys out and join in with that 4 that was already out there and multiply it by a 2. So I'm just going to bring these guys down. I'm going to have negative 2 radical 7 minus 9 radical 7. 2 times 4 is going to give me an 8. And then remember, we had that 7 left over. So now all my radicands match. So now I'm just going to deal with the coefficients. The negative 2 minus 9 gives me negative 11. And negative 11 plus 8 gives me a negative 3. The square root of 7 part is not changing. Remember, our index has to match as well as our radicand, and then we just manipulate the coefficients. So taking a look at number 5, I've got 2 times the square root of 45 minus 2 times the square root of 5. Since the indexes match, I'm going to try to change this 45 so it can match up with my 5. So I'll divide 45 by 5. That'll give me 9 and 5. My 9 I can break down. That 5 is delightful because now he's going to match up with that 5. So let's see, I have a group of 2 3s. Well, that's helpful because then I can bring that out and multiply it times that 2 that was already there. 3 times 2 gives me 6. My 5, that's what I want. He was left over. Now minus 2 times the square root of 5. 6 times the square root of 5 minus 2 times the square root of 5 is just going to give me 4 times the square root of 5. Taking a look at number 6, you'll see that we've got a 12, a 3, and a 20 as our radicands. Clearly none of those match, but since the indexes match as all being 2's, we can go ahead and try to see if we can get these radicands to match up. So with 12, I can't really do anything with this 3. So in my brain, I'm thinking, well, I really would like these other guys. Can I turn those into 3's? Well, 12, I can break that down into 4 times 3, and then my 4, of course, is 2 and 2. That seems like that's going to work out pretty nicely for me. I've got a group of 2 2's, so they can come on out and join in and be multiplied times that negative 3 that was already there. And then we have our leftover 3. So 2 times negative 3 is negative 6. And then we've got the square root of 3 right there. This guy, I can't really do anything to him, so I'm going to bring him down at 3 radical 3. Now my 20, let's see, 20 is not divisible by 3, but I can simplify that. Let's see, how about 4 and 5? And then my 4 I can break down as 2 and 2 again. So since again we need groups of 2, that 2 can come out and join in with that 3 that was already there. So 2 times 3 is going to give us a 6 on the outside. But what's left on the inside is a 5. You're going to see, well, that doesn't match with these 3's that I've got over here. But I can put these guys together because they're radicands with their 3's and their indexes match. So negative 6 radical 3 plus 3 radical 3 is going to give me negative 3 radical 3. But I can't do anything with this guy. This is as good as it gets. I just have to bring the 6 radical 5 down along with that. Sometimes you can make everything match and sometimes you can't. In this case, we can't do anything with that, so that's as good as it gets. Looking at our last example here, hopefully you're going to notice that this one is different because it has an index other than 2. Our previous examples all had an index of 2. This one has an index of 4. That's okay though, because if you note, each one of the radicals does have an index of 4. So we can try to make these other guys match, or make them all match up. Now there's nothing I can do to a 3, so that's kind of where my brain goes. I need everybody to be a 3, or at least somebody else to be a 3, so I can put these together. So that's what I'm going to divide them by. So 243 divided by 3, I think that gives me a 3 and an 81. 81, I can make that be 9 and 9, and then I've got 3 and 3 and 3 and 3. Well, remember, our index this time is a 4. So that means I need to have groups of 4. You'll note that I've got 5 3s, well, I can only take 4 of them out, and that's good for us because we can take that group of 4 3s. That's going to join in just as 1 3 out with that 2, and then we've got this 3 left. So that means I've got 3 times 2, which is going to give me 6. So that's going to be 6 times the 4th root of, then I've got that 3 left. Let's see, is 48 divisible by 3? I think it is, 3 and 16. So then we can have a 4 and a 4, a 2 and a 2, a 2 and a 2. Well, lucky for us again, you'll note that we've got a group of 4 2s. So those 4 2s are going to come out and join in with that -6 that was already out there. And then lucky for us, we've got that 3 that's going to remain underneath the radical sign. So 2 times -6, that'll give us -12 times the 4th root of that 3 that was left. Now this guy, he's good just the way he is because I've got the index of 4 and the radicand of 3. And remembering there's nothing out there other than the negative sign, so of course that really means it's a -1. So I've got 6 minus 12. That's going to give me, so now since everybody matches up, I only have to worry about the coefficients. 6 minus 12 is -6, and -6 minus 1 more is going to give us -7 times the 4th root of 3. So when you are adding and subtracting radicals, you must have the same index and you must have the same radicand. And then it's just like you're collecting like terms. The index you can never change. It's going to remain the same. So if the indexes don't match to start with, then you're out of luck. But if the indexes match, you can change the radicands by simplifying them as we've been doing in the previous lessons. So as long as your index and your radicands match, you can combine radicals by adding and subtracting.